let's talk about addition. Now remember the rule for addition. In order for things to be added together, in order for variable expressions to be added together, you need the same exact variables with the same exact exponents. So starting super basic, if I just give you 3x to the 4th plus 2x to the 5th, right? These are not considered like terms. Even though they're both base x, they're raised to different exponents. So this is actually completely simplified. We cannot combine this any further. So this just stays 3x to the 4th plus 2x to the 5th. Stylus point is all messed up. Okay, what happens if they are like terms? So let's say I have 3x to the 4th plus 2x to the 4th. Right, same exact variables, same exact exponents. How do we add? Keep the base and add their coefficients. So this is going to be 5x to the 4th. So I'm just quick going over each individual rule. So that's addition. Let's talk about multiplication. So the product rule tells us if I have x raised to the a power times x raised to the b power, you keep your base of x, and who remembers what do you do with the exponents? Fill up, right? Yeah.
You add the exponents?
You add the exponents. So if I have x to the 5th times x to the 3rd, that gives us x to the 8th. Now let's see when we put some coefficients in. If we have 3x to the 5th, y to the 4th, I'm going to use parentheses to show multiplication, times negative 2xy to the 3rd. Right, in the world of polynomials, 3x to the 5th, y to the 4th, is it a monomial, a binomial, a trinomial, or is it even bigger than that and we just call it a polynomial? What does this fall under? 3x to the 5th, y to the 4th. Zoya? It's a monomial. How, Zoya, how did you know? What distinguishes a monomial from a binomial? What do you need?
There's one term with no addition or subtraction.
Bingo. There's no addition or subtraction signs. This is one term. This is a monomial. A lot of times, even though you guys know the rules, sometimes you get in your own heads and then you start distributing this in. You're like, okay, 3 goes to the 2, 3 goes to the x, 3 goes to the y. No. And then you make it even crazier, and then you're like, x to the 5th goes to the 2, x to the 5th goes to the x, x to the 5th goes to the y. No. There is no distribution here. There's absolutely no distribution here. The distribution comes when you're multiplying like two binomials or a binomial and a trinomial. This is a monomial times another monomial. There's no plus signs. There's no minus signs. So what do? You multiply. You multiply the coefficients. So 3 times negative 2 is negative 6. And you multiply the like variables. X to the 5th. When there's no exponent, what exponent is really there? A 1. So then we multiplied our coefficients. 3 times negative 2. X to the 5th times x to the 1st is x to the 6th. Good, you add the exponents. Y to the 4th times y to the 3rd is y to the 7th. So here I have x raised to the a plus 5th power times x2 raised to the a minus 2 power. It's multiplication, right? That's all this is. So you just go back to your Algebra 1 basics. What is the rule for multiplication? Keep your base and do what with the exponents? Add, right? Keep the base, add the exponents. So we have, if you want to write this out, a plus 5 plus a minus 2. Combine your like terms. So this ends up giving us x to the 2a, and then 5 minus 2 is a positive 3, raised to the x raised to the 2a plus 3 power. Okay, you guys do this one. Are we still dealing with monomials? Yeah, we're still dealing with monomials. There are no plus or minus signs here. No plus or minus signs. There is no distribution. No plus or minus signs, no distribution. All right, who has an answer for me? Kai?
X to a plus 4b minus 2.
Mm-hmm.
And then y to a plus 2.
You got it. Okay, so now I'm going to change this up. Same idea, but I'm now changing the base to a number. If I have, don't write x to the fifth, but if I have x to the fifth, do we all agree x is the base and 5 is the exponent? How do we know that x is the base? Okay. It's bigger? We don't know. It could be a 1.
No, like the size.
Oh. Well, how come x isn't a coefficient?
Oh.
So I have x to the fifth versus 3x to the fifth. It's not really verse, but I want us to look at both of these. Right? Do we agree x is the base, 5 is the exponent? What's 3 here? What is that called? Coefficient, right? Base, exponent, coefficient. How do you identify the base? Noah?
The base has like a superscript.
Yeah, exactly. The base is what the exponent is attached to. So this exponent belongs to the x. Here, this 5 belongs to the x. Does it belong to the 3? No, it belongs to the base. So in this scenario, 7, is this a coefficient? Is this acting the same as this 3 is acting? Absolutely not. What is the 7 acting as? A base. This 7 is acting as a base. And if it's acting as the base, what is the rule for the same base? When you're multiplying, keep your base and do what with the exponents? Add them. A lot of students multiply these and say 49 raised to the 9th power. No, it is not set 49 raised to the ninth power. This is a base. The rule says keep your base and add your exponents. Now, this is nice of me. If exponent is greater than 5, leave in exponential form. Well, what does that imply? If exponent is greater than 5, leave in exponential form. If it's 5 or less, what do you have to do? Simplify it, right? So if it's greater than 5, you're going to leave it in exponential form. If it's 5 or less, you simplify it, meaning you multiply it all out. All right, last multiplication problem. 8 raised to the 2a plus 1 times 8 raised to the 4a minus 3. In this scenario, is 8 a base or a coefficient? Somebody besides Kai. Oh, what's your name? David? A base. So you keep your base and you're going to add your exponents. So this is going to be 6a minus 2. All right, now let's talk about quotients. So if I have x to the a over x to the b, what does the quotient rule tell us? Keep your base and do what with the exponents? Philip? Subtract them. A minus b. Top exponent minus bottom exponent. Okay, so keeping it simple, x to the 7th divided by x to the 2nd. Do we all agree that's x to the 5th? All right, well, what happens if I have x to the 2nd divided by x to the 7th? RF, right?
Yeah. You would still subtract them, but it would be 1 over x to the 5.
Exactly. So this brings us into the world of negative exponents. So I'm going to first talk about the negative exponents. It's always top exponent minus bottom exponent, right? But if you do top exponent minus bottom exponent, isn't that going to be x raised to the negative 5th power? In algebra, you never leave a negative exponent. Ever, 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 ever. You never leave a negative exponent. So let's take this a little further. Let's see what this looks like. X to the 2nd is an x times an x. X to the 7th, do we all agree, is 7 x's being multiplied together? Well, if the same thing's being divided top and bottom, doesn't that cancel out to 1? X divided by x is 1. So the 2 x's on the top get canceled out, but aren't we still left with 5 x's on the bottom? And since everything canceled out on top, it canceled out to 1. So that's 1 over x to the 5th. What does that tell us? Anytime you have a negative exponent, how do I make it positive?
Put it to the denominator of the fraction.
Put it in the denominator of the fraction. Guess what? What if it's in the denominator? Where do you think you're going to move it to? The numerator. So let's write this out. X raised to the negative n power is 1 over x to the n. And if I have 1 over x to the negative n power, meaning our negative is in the denominator, you're going to move that up to the numerator, and that's going to be x to the n. All right, one more special rule. What about something raised to the 0 power? So I'm going to do it over here to the side. If I have x to the 5th divided by x to the 5th, isn't that x to the 0? Okay, but what's anything divided by itself? Tejas. 1, you got it. So this is going to be 1. So what does that tell us? Anything raised to the 0 power is 1. So that's our last thing, special thing here. All right, let's keep going with division. 4x to the 10th divided by 24x to the 6th. Now keep in mind, you're still dividing. This is dividing. So when you have 4 over 24, does 24 go into 4 evenly? No. But can I simplify 4 and 24? Yes. So I'm going to divide top and bottom by 4, which gives us 1 in the numerator and 6 in the denominator. But then we still have x to the 10th divided by x to the 6th. What do you do with these exponents? Subtract. So where is that x to the 4th going to go? Is it going to go in the numerator or is it going to go in the denominator? Layla? Numerator, you got it. When you're dividing, as long as it's all positive, wherever the bigger exponent is, that's where your variable will go. So see how 10 is bigger than 6? So when we divided, we ended up in the numerator. If 10 was on the bottom, we would have ended up in the denominator. So wherever the exponent is bigger when you're dividing, that's where it ends up. All right, you guys do this one. X to the 7th, y to the 2nd, divided by x to the 5th, y to the 9th. Who has an answer for me? Tori. Perfect. How many people got that? X to the 2nd over y to the 7th. Great. All right, let's keep going. I don't know what number we're up to. Has anybody been keeping track? 1, 2, 3, 4, 5? No? I don't know. I just make up numbers. Okay, so let's say we have x to the 6a minus 3 over x to the a plus 2. If you center yourself and you keep just going back asking yourself, what is my Algebra 1 rule? You won't ever stray. So here, what's my Algebra 1 rule? Keep your base and do what with the exponents? Subtract the exponents, but be careful now because now I'm not just subtracting monomials. I'm going to take 6a minus 3 and subtract from 6a minus 3 a plus 2. But now not just the a gets subtracted, the whole a plus 2 gets subtracted, so that's why I need the parentheses. So that negative goes to the a and it goes to the 2. So this is going to give us x to the 6a minus 3 minus a minus 2. Can I simplify that? Absolutely. So this is x to the 5a minus 5. All right, I want to chat about this for a second. So technically, what this is x to the 5a times x to the negative 5th. Do you guys agree? that this and this are equivalent, because when you're multiplying, you keep your base, you add your exponents. So I could technically change this to this. So do in some form I have a negative exponent here? Yes, that's okay. As long as the variable is a positive exponent, is a positive coefficient, then you can keep it like this. As long as the variable is a positive coefficient, you keep it like that. Because then if you went back and did x to the 5a over x to the 5th, we're not completely simplified anymore, because now we can divide the x's. Do you see what I'm saying? So this is okay. As long as we keep the variable coefficient positive, we can make that 5 negative up top. It's fine. Okay, next one. Tell me, 5 a base or 5 an coefficient? Is 5 a base or 5 a coefficient? It's a base. Keep your base, subtract your exponents. Can I leave this as 5 to the 3rd power? No, good. So we have to multiply this out. 5 times 5 times 5, which is 125. All right, let's talk about a power to a power. All right, power to a power. That's when you have some power raised to another power. The rule is, let's write out the rule. X to the A raised to the B is going to be X to the A times B. You multiply them. So X to the 3rd raised to the 4th is X to the 12th. All right, let's throw a coefficient in there. So now I'm going to have 2x to the 4th raised to the 3rd. All right, this is so huge. Right now, inside my parentheses, is this a monomial or something bigger than a monomial? Tori? It's a monomial. As long as what's inside your parentheses is a monomial, you can distribute in that exponent. As long as it's a monomial, you can distribute in that exponent, which tells us this is going to be 2 to the 3rd and then x to the 4th raised to the 3rd. 2 to the 3rd is not 6. What is 2 to the 3rd power? James? 8. What is x to the 4th raised to the 3rd? X to the 12th. You don't have to write this down, but I need to show you. Inside my parentheses, is this a monomial or something bigger? It's bigger. If it's bigger than a monomial, you are not allowed to distribute in that exponent. You cannot do this. No, that is wrong. That is a huge no. Honestly, if I see it, it angers me, and I usually take close to full credit off. Right? No, that's like a rookie mistake. This is 2 plus x to the 4th times another 2 plus x to the 4th. You need to double distribute, FOIL, whatever your Algebra 1 teacher used to call it. What does that mean? 2 times 2 is 4. 2 times x to the 4th is 2x to the 4th. X to the 4th times 2 is 2x to the 4th. X to the 4th times x to the 4th is x to the 8th. So this ends up becoming x to the 8th plus 4x to the 4th plus 4. if you would have distributed in, if you did it wrong, if you did 2 plus x to the 4th and you distributed in that exponent of 2, you would have gotten 4 plus x to the 8th. Are these two answers the same? No. So what's the moral of my story here? That's wrong. The moral of the story is that if it's bigger than a monomial inside the parentheses, you cannot distribute in that exponent. You have to just sort of write it out and distribute and FOIL, double distribute, whatever you want to call it. All right, let's keep going. All right. So this seems like it should be obvious, but I think we still mess it up sometimes. So there's a big difference between this and that. Who does the exponent belong to here? Layla?
The x.
The x. Is that negative? That's really a -1 here. This is really a -1. Is that -1 getting that exponent of 4? No. So this is just -x to the 4th power. There's nothing to do here. In this scenario, who does the exponent belong to? What's your name? Alexandra?
The negative x.
Yeah, it actually belongs to the parenthesis, right? So what does it mean if it belongs to the parenthesis? That means it belongs to everything inside the parenthesis. So now, is this negative still now getting that power of 4? Yeah, so remember this was -1. So this is -1 to the 4th power and x to the 4th power. Well, a negative raised to an even exponent is positive. A negative raised to an odd exponent is negative. So this ends up becoming x to the 4th. Big difference. Parentheses play a huge role here. All right, let's keep going. That's not a y, that's a 4. All right, is that negative on the outside getting that exponent? No, it belongs to the parenthesis, therefore it belongs to everything inside the parenthesis. Can I distribute in that exponent? Absolutely. So we end up getting -x to the 20th, y to the 16th. All right, that d belongs to the exponent. The d belongs to the parenthesis. Inside my parenthesis, is it a monomial or is it bigger than a monomial? It's a monomial, no plus or minus between the x and the y. So that means I can distribute in this exponent. What does that mean? This is x to the a plus 2 raised to the d power and 5y raised to the 5b raised to the d power. But now I have to multiply d and a plus 2. But if a plus 2 is a binomial, what do I have to do with that d? It has to go to every part of that. So the d goes to the a and the 2. So this ends up becoming x to the ad plus 2d, y to the 5bd. Philip?
I had a a question on the last example that we did. When it comes to like a negative symbol outside of parentheses, when we're done like simplifying the exponents like together and multiplying them, should we distribute the negative as well?
Well, there's nothing to distribute here, right? Because this is a monomial. If there were a plus sign, then you distribute it, but there's not. So this is one term altogether. Does that make sense?
Yeah.
Okay. Okay, something else we should know. If I have x over h raised to the y power, do we agree this y, it looks like a 4 because my stylus is all messed up. I need a new one. You know what? I'll make it the 4th. That makes it easier. All right. Do we agree that this 4 belongs to the parentheses? And if it belongs to the parentheses, doesn't it belong to everything in the parentheses? So what you do is you give that numerator the exponent of 4, and you give the denominator the exponent of 4. So it's x to the 4th over h to the 4th. Somebody tell me, what do we get for number 6? Arav?
I got 8x to the power of 9 over y to the 15.
How many people got that? Good. Anybody need to see me do it? All right, let's keep going. All right, let's talk about order of operations. All right, so we follow PEMDAS. So when we have multiple operations like 3x to the second times, in parentheses, 5x to the third, close your parentheses, raised to the second power. Do we all agree we have multiple operations going on here? I have multiplication and I have exponents, right? I have multiplication and I have exponents. According to PEMDAS, do I simplify the power to a power first or do I multiply first? Danny? Power to power. So now I'm going to simplify this part, and I'm going to get 5x to the third raised to the second power gives us 25x to the sixth. Now I take that and I multiply that by 3x squared. So now you multiply the coefficients. 3 times 25 is 75. X to the second times x to the sixth is x to the eighth. Right.
That exponent is negative on the outside of the parentheses. Would you distribute it and flip the?
So I'd flip it first to make the exponent positive. We're going to do a problem like that, and then distribute it in. All right, let's keep going. All right, write it down and then we'll chat about it. Okay, so according to PEMDAS, we have parentheses, we have exponents. Clearly, we're working on this side first, right? You have the choice. You can distribute in that exponent of 3 to the numerator and the denominator if you want, or you can simplify inside the parentheses first. I'm going to opt to simplify inside the parentheses first. Now, see this x 2 minus a, and this x a plus raised to the a plus 3 power, don't they have the same base? All right, so what I'm going to do is technically this is a negative a, right? So can I bring it up to make that a positive? If I bring this up to make that a positive, how would it be written down if I wanted to bring that up to make the a positive? So we have x raised to the a plus 3, and now I'm going to bring up that x. Anybody know? We have to negate the whole exponent. If I'm negating this whole exponent, the positive 2 becomes negative, and the negative a becomes positive. So this becomes x raised to the a minus 2, or the minus 2, negative 2 plus a. Everybody okay with how I got this? Yeah? Okay. And then we still have times the 2b. But now there's no more denominator. Do we see that? There's no more denominator there. All right, now let's simplify inside those parentheses. I'm going to keep my x, and I'm going to end up with 2a plus 1. Y to the 2b, all raised to the 3rd power. If I'm going too fast, just let me know. So now, because it's a monomial, do we agree it's a monomial inside our parentheses? I can distribute in that exponent. But when I distribute into the 2a plus 1, what does it become? Phil?
X to the 6a plus 3 times y to the 6b.
So perfect. Does everybody know how Phil got the 6a plus 3? Does anybody need that explained? Okay, let's keep going. We're not done yet. Now we take that and we're going to multiply it with the x raised to the 2a, y to the b. So now we're going to have x, and now we're multiplying. It's no more power to a power. When you're multiplying, what do you do with the exponents? Add them. So this is going to be x to the 8a plus 3, y to the 7b. Okay, let's say I have 5 over 2 raised to the negative 3rd power. What am I going to do? I'm going to fix that negative exponent. How do I fix the 2 to the negative 3rd power? How do I make that negative exponent positive? Bring it to the numerator. So then it becomes 5 times 2 to the 3rd power. Can I leave it an exponential, or do I have to multiply this out? We need to multiply it out. So it becomes 5 times 2 to the 3rd power is 8. Can we multiply a 5 and an 8? Absolutely, that is 40. Yeah, could you just do the whole pass? Okay, let's keep going. Anything raised to the 0 power is what? 1. Doesn't this 0 belong to the parenthesis? So what does this mean? This whole parenthesis becomes 1. So my whole numerator becomes 1. Then I have x to the negative 5th, y to the 2nd. We are never, ever, ever allowed to leave negative exponents. So what do I have to do with this x to the negative 5th to make it positive? Michael? Flip it to the top. So that's x to the 5th, y to the 2nd. All right, I want you guys to do this next one on your own. What do you think I'd recommend you do first here? Any guesses? Tori? Yeah, I would take care of the negative exponents first. You don't have to. That's just where I would have started. I would have taken care of the negative exponents first. Can I go over this? Okay. So I'm not worried about right now the negative 15 and the 5. I'm going to leave them right now. I'll deal with that later. What I am going to be concerned with are these two negatives right now. So I'm going to make them positive. So I'm going to move the x to the 3rd down. And I'm going to move the y to the 3rd up. So then I have negative 15 over 5. And then in my numerator, I can multiply. Y to the 3rd times y to the 4th is y to the 7th. X to the 2nd times x to the 3rd is x to the 5th. Everything's positive. Now, I'm still not completely done, because can I simplify negative 15 divided by 5? Yeah, that becomes a negative 3. Are you allowed to have a negative coefficient? Is that okay? Yeah, you're just not allowed to have a negative exponent. So this is negative 3x to the 7th over x to the 5th. All right, let's look at this one. I'm going to have a lot going on here. So Tori, this is sort of what you had asked me about. Sienna?
Why is it 5? I mean, x to the 7. We have y to the 7.
Oh, I put an x in both locations. Sorry. That's wrong. That is a y. Thank you. Okay, write it down.
Simplify it to negative 3 over 1, right? But if you, in another problem, we did 5 to the 5th over 5 squared, and you would leave that with a base of 5, because it's the same base of it.
Tell me one more time what you're saying.
So not when you had negative 15 over 5 as
Mhm.
the two coefficients.
Yeah.
But in another problem, we had, oh wait, it's a coefficient.
You're okay?
Yeah.
Okay. All right. Did everybody copy down number 6? Okay. Now we have exponents, but we also have parentheses. So I'm for the minute going to ignore that negative 2 on the outside. I'm going to work inside my parentheses. Inside my parentheses, I'm going to fix my negative exponents. So when I fix my negative exponents, I'm bringing r to the third down. And what else am I going to move? So I brought r to the third down. What else should I move? Michael? Yep, I'm going to move s to the first up. The t to the first stays on top, and the t to the third stays on the bottom. All right, now I'm going to simplify inside my parentheses. Now I'm going to simplify this. So now we're going to have s to the third times t to the first. And in the denominator, I'm going to have r, was that the second and third? Yes, r to the fifth times t to the third. I'm still not done, right? I'm still not done simplifying inside my parentheses. Why am I still not done simplifying inside my parentheses? Tejas?
You didn't like cancel out the t on top.
Yeah, so I have t to the first divided by t to the third. Where is that t to the second going to go? Is it going to go in the denominator or is it going to go into the numerator? Layla? Denominator, perfect. So now we are s to the third over r to the fifth t to the second. Okay, now I simplified what I could inside my parentheses. Do you see how our exponent is negative, but it belongs to the parenthesis? So now I need to make that exponent positive. The way to make this exponent positive, if it belongs to the parenthesis, you flip the complete fraction. So the denominator becomes the numerator, and the numerator becomes the denominator. So this ends up becoming r to the fifth, t to the second, over s to the third, raised to the positive second power now. Now I have that positive second power. It still belongs to the parentheses. What am I going to do? I'm going to give it to the numerator, and I'm also going to give it to the denominator. Do we agree it's monomial over monomial? So can I distribute in that exponent? Is that okay? Absolutely. So that's going to be r to the 10th, t to the 4th, all over s to the 6th. Okay, we're done for the day. You do have homework. It is in your textbook. I will put it on Classroom, but it's also in the syllabus. You drop